Good afternoon. Welcome to this SVC presentation, differentiated by world-class design for reliability. My name is Matt Lacy. I've been at Advanced Energy as a reliability engineer for more than 20 years. I'm joined by Dr. Gopal Mohanty, the Director of Reliability Engineering at Advanced Energy. Dr. Mohanty joined AE 3 years ago, and prior to that had extensive experience in both the medical industry and the automotive industry. You know Advanced Energy as an innovative technological company that provides high-value power supplies. What I want to talk to you about today is our world-class design for reliability process that allows us to consistently deliver products that are highly reliable to our customers and the markets that we serve. Advanced Energy is a billion-dollar worldwide company that continues to provide solutions to numerous industries. Nearly every electronic product in the world is made using advanced energy technology. To meet the demands for high reliability for these products, we've established a design for reliability process. This is a methodical approach that is customized for the products, and it results in high reliability, faster time to market, and lower cost of ownership, ultimately to achieve superior customer satisfaction.
What is DfR? It basically provides a framework that helps build reliability into products at early stage of product development. It helps minimize surprises downstream. DfR emphasizes on system analysis to understand the customer use conditions and how our product interacts with the customer tool. Components that affect product's performance the most are tagged as critical, and these critical components are designed well and managed in manufacturing and in the field. The approach of DfR helps build robustness of product early in design rather testing to verify design as many companies do. The governing principles of DfR is to apply the DfR tools to reduce variability in product performance and degradation all through product life cycle, make it more durable, and predict product failures. This approach enhances the product uptime, thus minimizes the interruptions in customer processes.
Let's take a look at some of the benefits of the DfR approach. On this slide, I've got a graph showing the product development process on the x-axis and the problems discovered during that process on the y-axis. As an example, we have some of the phases that might be used for a product development process. Generally, you start by defining a product, and you end up by manufacturing the product and beyond servicing it. The concepts you identify and define, design and develop, move to volume manufacturing and beyond. So as we look at this, using a conventional test and fix reliability approach, a lot of times you'll find some things early on, but the majority of your findings come when the design is completed, the hardware is available, you start testing, you start doing margin testing, you have your hands on the design, and you want to find the problems and fix them. And it costs a lot. If you have a board turn right before you're set to release the product, that'll either push the product release, or you have to have a heroic effort to be able to fix the problem, get it back in, retest, verify it. So it takes a lot of resources to find and fix problems at this late stage in the product development process. What the idea of DfR is, or early DfR, is we want to push the findings to the left. We want to end up with a mature product that we aren't finding new issues on before we release it. We want to meet our time to market requirements instead of being pushed out by failures or board turns that we didn't expect. And what that does is it lowers the overall cost of the development. So instead of finding big problems either in the field as your reliability is improving, or right before you launch, you're finding problems early on, during the definition and planning phase, during the design phase, and during the verification phase. So that's the idea of the benefits of the DfR approach. Mature product at launch, faster time to market, overall lower cost of development. Now let's take a look at the DfR process flow and start to introduce the DfR elements that support this DfR process flow. As you see, I've taken the PDP process and loosely kind of arranged it so that it follows the DfR process flow. I've also taken the elements and loosely how it follows. So we're just going to walk around the circle here of our process just to kind of understand how we achieve high reliability products through the DfR process. So it starts with VOC, or voice of the customer, and the existing knowledge we have on the product. So whatever design we have, we want to understand what the needs are of the customer, what the requirements are. We want to understand what we've made in the past, if we're reusing items, if we have a high or low failure rate on the components that are being reused, if we have risks associated with the new components or new technology that's being used. We put that all together. We call that in-depth understanding. We want to get a good understanding of what it is we're trying to do with this product and what we know of it as we start. We have product requirements. We put together a DfR plan that includes the reliability requirements. We plan out the resources that are going to be needed from a reliability perspective, the man hours, the tools, the anything that might be used or required during the planning process. So we do planning, we do analysis activities, we do testing activities, we have third-party resources. All these things are part of what we're trying to define as we start this project. We want to get to upfront analysis. System analysis, we start at system level. We don't have to have a design finished to be able to analyze it. We want to take the function block, the inputs and outputs at a subassembly or section level even, and understand what are the failures, what are the implications or effects of those failures, how do we, what are the risks in that particular subassembly. We want to start at the system level to analyze it. As we get more information, we will update the reliability model, the reliability block diagram. We'll update the reliability prediction. We'll take information as we get it to make it better, but we want to start before everything is locked down. The goal is to make an impact on the design. So as we do that, we understand what are the key characteristics, both at the subassembly level and the unit level, that we need to monitor during our testing or production. We feed these key characteristics into the manufacturing analysis. As we start to get hardware, then we want to explore the design margins. We start to do the testing. We have a good idea of what potentially are the weak spots or what we're looking for. What are the operating points we want to operate? What conditions we want to test it at? So we start to look at those design margins. We use both of this, both the analysis activities and the testing activities, to estimate where we are compared to our DfR metrics. So we want to do upfront analysis. We want to do rigorous testing that's also optimized. We don't want to do testing that is non-value add, but we want to cater our test plan, customize our test plan to be able to get the most value in the shortest amount of time. Same in production. We want to optimize the testing that we go through. If there's a reason to do some kind of a screen, a hash test, a burn-in, we definitely will do that. And on new products, we potentially will start with that and then back it off. But we want to ultimately optimize the testing, both in the verification phase and in production. And then, of course, we have continuous improvement, things that the do we find in either field failures or analysis activities that may not pertain to this design, but were found in a different design. We can use those to continuously improve the product.
Now let's review the DfR activities we perform at various stages in product lifecycle during identify and define stage, design and development stage, and volume manufacturing. Let's be clear that these stages are not product development phases as we apply at AE. These stages are broad segments within product lifecycle. During identify and define stage, depending on the changes being made to the product, a set of activities are performed to gather market requirements. Activities include competitive product analysis, customer use analysis, and product requirement analysis that would have impact on product reliability. Next set of activities performed in design and development stage is to develop the design and optimize it in a way to ensure the product performance meet the reliability requirements. Later in product development, when the product is ready to get transferred to manufacturing, a set of activities are performed to execute proper controls around product manufacturing and quality of products shipped to the customer. In order to gain efficiency in performing these activities, we have instituted a suite of computer-based tools that automate most of our workflows.
I want to briefly touch on DfR testing as part of our DfR process. Ultimately, we want to find and fix as many failures as early as we can by analysis, but testing still plays an important role. One important thing we can do with testing is before we even put a component into a design, we can subject it to component level testing, looking for specific failure modes of the device so that we're ready to use that device in the design. We also want to verify through our testing that we didn't miss anything, that we meet our internal derating guidelines, that we understand what our margins are on the design. So testing plays an important role in our process, but we want to optimize that testing to get the most value that we can. So we'll do thermal testing. We'll try to test like the customer tests, even on plasma systems. We will understand what the next weakest link is by our margin testing and whether or not that's acceptable for the product. And then we will optimize our production testing. We want to add value during the manufacturing testing and make sure that we're not wasting resources doing tests that ultimately are 100% yield. So testing still plays an important role in our process. We just want to optimize what we do with testing. All right, in conclusion, Advanced Energy employs a world-class design for reliability process. This is a consistent, methodical approach. We want to find and eliminate defects early on. We want to accelerate the design maturity. We want to lower the cost of development and the product life cycle costs. Each product has a customized plan. We plan the resources. We do different analysis and testing activities depending on what the risks are for the product. And this results in higher reliability products, faster times to market, overall lower cost of ownership, and ultimately our goal is superior customer satisfaction. Well, this is, as they say, the tip of the iceberg. You may have questions, comments. We'd love to answer some questions, and also you can feel free to contact us at these with this information. Thank you for listening to this presentation. Look forward to talking to you in the future.